The details in this image far surpass anything that we have been able to obtain from the ground. We just got our last set of images yesterday, so I haven't even seen them yet, so I can't show them to you yet, but I do have something I'd like to share with you, and that is Hubble's view of the full disk of Jupiter in glorious color. This image is our highest resolution image of Jupiter since 2007, when the New Horizons mission flew over the cloud tops of Jupiter. And you can see the impact site down in the bottom there, but you can also see fantastic structure and detail across the rest of the disk. This was an extremely challenging observation to make. It was tuned for science, not for public release. And so Michael Wong at the Space Telescope Science Institute had to do a tremendous amount of work to be able to recombine our different colored filters into this beautiful image, but it's fantastic. Now, this illustrates a superb aspect of the revitalized Hubble, and that is its wide field imaging capability. This is something that all of us are really going to be taking advantage of, is the ability to get very large pictures. The color composite also talks about the different kinds of colors that we see. This is made with visible wavelengths, red, green, and blue, but we also have some fantastic ultraviolet and near-infrared data that we will be analyzing in great detail. More broadly speaking, the true power of Hubble lies just in the creativity of the collective minds of our community. As this final image, which is a montage of the images that you've seen before, illustrates, every field of astrophysics, whether it's our local neighborhood of planets, nearby stars and their attendant planets, galaxies, clusters of galaxies, out to the edge of the universe, every field has questions that are awaiting the power of Hubble. The brief descriptions of the science that you heard earlier, they just barely scratch the surface of the science we're going to do. You're only getting the tiniest taste of what the astronomers are planning to do with Hubble over as many years as it can last. We in the community are already starting to get our data, and we're giddy with the quality of the data that we have with this new telescope. We're especially excited to have the spectroscopic capability restored to Hubble. Hubble spectrographs, and I can say that in the plural now, they permit us to work on a mind-boggling array of scientific questions over a huge range of sizes. As you heard, we're talking about atoms and molecules and how they combine and interact with their environment. But we're doing that on scales that are, dare I say, astronomical. So again, we are entering a new era of astronomy. Hubble's new beginning is just setting the stage for what's going to be coming, including the next great space observatory, the James Webb Space Telescope. With this new beginning for Hubble, we can now see more clearly and understand more deeply the processes that create and shape and drive change within our universe. Hubble is back in action. Together, NASA and Hubble are opening new vistas on the universe. And I'll turn it back to you, J.D.
Thanks, Heidi. Well, it's time now for our question and answer session. And before we begin, just a few caveats. If you would, wait until we get a microphone to you. Please identify yourself and your media affiliation before you begin. And if you would, tailor your questions to a specific panelist if you can, to avoid any confusion in that. And with that, let's start with Seth from AP.
Seth Lawrence.
It's on.
Seth Lawrence, AP. Actually, for Dave, one question with a follow-up. These all seem to, as you said, all except for one were in our galaxy. How far, what is the deepest you've looked so far? How does that compare to how far you expect to be able to look now and how far you've been able to look in the past?
Yeah, I can't give you